Hello everyone, welcome back to file programming in C. So in this session we'll talk about file positioning functions which are fseek, ftell and rewind. So let us get into the details. First of all, let us see what is the usage of this file positioning functions. Why do we need? Okay, so far we have seen the sequential access of files, right? So now if I want to have a random access to the file, so that can be done with the help of these file positioning functions. Okay, so now let's see each method. So first let us talk about the fseek method. Okay, so fseek function is used to move the file pointer position to the given location. So let us first see the syntax and then we try to understand what is meant by moving the file pointer to a given location. Okay, so the fseek will always return you an integer value. It will always tell whether it is successful or an erroneous one, and it will accept three arguments. Okay, so first one is a file pointer, then the second one is an integer which is an offset. So this offset can be number of bytes or number of characters. Okay, so moved from whence or the current file position. Okay, so this is dependent on this third argument, whatever value are supplying, from where you want the offset, whether you want it from the beginning of the file or from somewhere else. Okay, so this where from will tell you the current file pointer position from where offset is added. Okay, so for this, three possible values are possible. First one is seek set. Either you can give a predefined constant, it should be given in caps only. Either you can supply seek set or you can even give an integer value 0. This will move the file pointer position to the beginning of the file. Okay, so the usage you can see here. The first argument is a file pointer. Then I'm giving a number 7. So that means it should be moved 7 bytes or 7 character positions ahead depending upon the file that I'm using. And seek set. So from the beginning, it should move to 7 positions ahead. The next possibility is seek current. Either you can give this predefined constant seek current or you can give an integer number 1. So this moves the file pointer position to a given location. So here you can supply the value that you want. So you can give an integer value from which position you want the file pointer to be positioned. Then the last one is seek end, or you can even give an integer number 2. It moves the file pointer position to the end of the file. Okay, so when you are moving to the end of the file, if you want to retrieve the data in reverse, so then here in place of integer, you should give a negative value that I will show you in an example. So here you can see the file seek operation. Here I have taken a structure. So here each block, okay, so each block is one structure. So under that structure I have multiple values. Okay, so this is the size of each structure, which we can call as size of each record. Now initially let us assume our file pointer is at the beginning. So now with the help of seek set, what seek set will do, so it will start positioning your file pointer to the beginning of your file. So from the beginning of the file, it should move. What should be the offset? 4 into size of structure type. Okay, so 4 records ahead it should move. So now you can see the file pointer is positioned at the 5th record. If I am using seek end, okay, so your file pointer will be moved to the end of the file. Okay, so from there, in reverse direction, 4 into size of structure type. Okay, 4 records I want to move backwards. Okay, 1, 2, 3, 4. 4 records we have moved back and your file pointer is positioned here. Okay, so it is moving in backward direction. You can use seek and whenever you want to go back in direction. So now seek current. Okay, so here you can supply a number. So what is the number that we are supplying here? 2 into size of structure type. Okay, so as of now, your file pointer is here. So from here, it should move 2 records ahead. So it 1, 2, and your file pointer is here. Okay, so this is how your third argument of fseek will work that whence from. Okay, so from which particular position you want to move the file pointer to which particular location. Okay. So next let us discuss about ftell function. So this ftell method will return you the value of the current position of the file marker in the file. Okay, so currently where is our file marker? So that will be returned in terms of number of bytes from the beginning of the file. Okay, so it measures the position of the file by number of bytes relative to 0. So okay, always the beginning will be taken as number 0. So from there, how many bytes it is moving or how many records it is advancing, how many records ahead it is, will be returned by this ftell method. So here you can see the syntax. It will always return you an integer value. To this ftell method, we'll be passing the file pointer. And here you can see an example. Okay, so from the beginning, here the return value is 16. So that means from the beginning of the file, 16 bytes ahead is our file marker. Okay, so starting with 0, 0, 1, in this 4 bytes are present in each block. So 4, 4, 16, and it is pointing currently to 17. So that is the value that is returned. Okay, starting with 0. 16 is your 17th byte. Okay, so here 0 indicates starting or beginning of a file. Suppose if your ftell is returning you a value 0, so that indicates it is at the starting or beginning of the file. So 1 is the offset of 1 byte. So here what is the offset value returned? 16. So that means it is 16 bytes ahead. If suppose if it is returning you -1, that indicates an error. When will you be getting an error is whenever you are pointing to a file which is currently not in use, or if the file is not opened successfully. So in that cases, you might get an error. So now let's talk about the rewind function. I hope all of you know what is the usage of this rewind. I did not tell you. Okay, so this function is used to move the file pointer to the beginning of the given file. Okay, so here you can see the syntax. Rewind file pointer. Always it will return your void value. You need not have a return time because it is not returning anything, but it is setting the file pointer. So here you can see before rewind, say suppose your file marker is here. So now after rewind, it will be set to the beginning. So here is your file marker. Okay, hope you have followed the syntaxes and the usages of these 3 methods. Now let's have a hands-on. All of you be ready with your device. Let's include our header file. Let's also include stdlib.h. For exit method, let's declare our main method. Okay, so we need a file pointer. So let's declare a file pointer. Let me name it as f1. And let's open this file. So okay, so we are not using any of the existing files. I want to open a file. Okay, so with the help of fopen, let's open this. Okay, let's name this file. I want to name it as file positioning.dat. And let's open it in, since it is a new file, let's open it in write mode. Okay, so let's check whether our file is opened successfully or not. Okay, if f1 is equals to null, let's give an error message. Error in opening the file. And let's exit from the file. Otherwise, else, let's start the usage of our file positioning functions. Okay, so first I want to show you the usage of ftell method. What will be the output of ftell? It returns you the file size in terms of number of bytes, right? result of ftell or size of file. Size of the file. Size of the file is always it will return you a number in terms of number of bytes. So let us call the method ftell. Okay, so let's run this code. Okay, so for this ftell we have to pass the file pointer. So see, the size of the file is 0 because I have not written any content into this file. Okay, so now let's write some content to the file with the help of fprintf. Let us write, let's practice file positioning functions. Fseek, ftell, and rewind. You can see I'm separating them with a new line character. Now, once again, let's make use of this ftell and see what is the size of the file. Okay, so how many characters that we have returned to the file and what is the size? Let's see. Okay, so we for fprintf we have to pass the first argument as the file pointer. Purposefully I'm making some errors so that you will be able to debug your code. Whenever you are facing some problem, you should be able to correct it also. Size of the file is 73. So that means 73 characters have been copied to this particular file. So let's open this file and see whether those many are there in our file or not. So what is the name of our file? File positioning.dat. So here you can see, let's practice file positioning functions fseek, ftell, and rewind. Okay, so since we have opened the file in write mode, you can see the cursor is waiting at the beginning only. Okay, so you can count all these characters that you have given in this printf statement, including backslash n. This also will be taken as a character, all the spaces, backslash n, everything. Okay, so this everything will be treated as separate characters. So if you see, totally 73 characters are there in this. Or if you want to see the exact count, even you can give a small value. Okay, so yes, so now let us see the usage of fseek as well. Let's use the method fseek. The file pointer is f1. What should be the offset? So let us give an offset by 35. And from where shall we give? Either you can give a number 0, which says seek begin, right? Which is seek set from the starting of the file. Okay. Oh, I didn't do any operation here. Just we have set our file pointer 35 positions ahead. And now let's see what is the size of the file. Okay, so out of 73, when you have moved your file pointer to 35 locations, 73 minus 35 should be the result. Let's compile. So here you can see the size of the file is 35. Okay, so from where? From the beginning, you have given an offset of 35. Okay, so the result is not 73 minus 35. The result is 0 to 35. So you have moved your file pointer 35 positions ahead. So currently it is at the 36th character. So since it is starting with 0, so 0 to 35. Okay, so only it is returning you a value 35. Size of the file is 35. So always you can see from the beginning where is your file pointer. So that will be given by ftell. So now let us change this value. So let us give seek end. Even you can use the constant seek end. You can just change these values and see. Okay, from seek end, I want to give minus 35 because you are going in reverse direction. So here you can see the value 38. So now 73 minus 35 has worked out and it is giving you a result of 38. 0 to 38. From the beginning, how far it is. ftell will always give you the number of bytes from the beginning of the file only. Okay. So hope you have followed. Let us see the usage of rewind as well. Okay. So right now, your file pointer is at 38 location, right? Let's use rewind. And once again, let's print the size of the file. So now you will be getting the size of the file as 0 because the cursor is at the beginning. Here you can see it is 0. Hope you have followed. If you have any queries, please let me know in the comment section. If you like the content, do like, share and subscribe. Thank you.